Once you have your radius of convergence, you need to check for endpoint convergence. So the general steps for finding the radius of convergence, the endpoint convergence, is you find x that makes the ratio test true, and make sure you do those absolute values. You identify r and the endpoints, and then you need to check those endpoints. So if I look at my series, I can have one of these four cases. One case where when I put in x equals c minus r, then it's possible for this series to diverge. And you literally put x minus cr, x is c minus r, into the original series, and then use a ratio test, see if it converges or diverges. And then you put in x is c plus r. And in this case, it diverges, and so you'll have the open brackets. It's also possible for one endpoint to converge while the other one diverges. And the last case is for it to converge on both endpoints. Now let's find the interval of convergence for this function right here, series right here. So let's look at the limit as n approaches infinity of the absolute value. Now don't forget your absolute value signs. X to the n plus 1 divided by n plus 1 divided by x to the n divided by n. We can use the ratio test here. So this is the limit as n goes to infinity of x to the n plus 1 divided by n plus 1. And all I'm doing is rewriting my fraction here. Don't forget your absolute value signs. This is the limit as n goes to infinity of the absolute value. Let's see, what's going to cancel? I'm going to lose x to the n. I'm going to be left with 1x of n divided by n plus 1. And this is all going to be times x. So if I take this limit, this is the absolute value of x. So I've used the ratio test, and I want to make it less than 1. So I need absolute value of x to be less than 1, which tells me my radius of convergence is 1. And my interval is from -1 to 1. Now I need to check my endpoints. This is the second point. So here are my endpoints, -1 and 1. So I need to check endpoints. All right? Now, I'm going to take x equal 1. I'm going to check the left endpoint first. Oops. X equal 1, and I'm going to put it into my series. The sum, n goes from 1 to infinity of 1 to the n divided by n. So when x is 1, I guess I'm checking the right endpoint. Now this is divergent. This is harmonic. And so this diverges. So now let me check. Now I'm going to check the left endpoint. So this is the sum. N goes from 1 to infinity of -1 to the n divided by n. Well, this is, remember we could use the alternating series test. This is the convergent. It's not always going to be this clear. Sometimes you have to do a little work. This is converging because it's the alternating harmonic series. All right, so my interval of convergence in this case is, I'm going to include -1, but not include +1. And the radius of convergence is 1. Now let's do one that's not centered at 0. Let me look at the limit as n approaches infinity, and we put my absolute values. -1 to the n plus 1 times x plus 1 to the n plus 1 divided by 2 to the n plus 1 divided by -1 to the n, x plus 1 to the n divided by 2 to the n. All right, that's kind of a mess. So this is a limit as n approaches infinity. Now clearly we can drop off the negatives. Those are going to go away. I just don't like writing them. Absolute value, x plus 1 to the n plus 1 divided by 2, n plus 1, times 2 to the n divided by x plus 1 to the n. All right. Now, what will cancel here? I'm going to lose that n and that term. I'll lose that n and that term. So this becomes the limit as n goes to infinity. What am I left with in the numerator? The absolute value of x plus 1 divided by 2. Ah, okay. And where is that less than 1? Well, that's just wherever x plus 1 over 2, the absolute value, is less than 1. So I have x plus 1, absolute value, has to be less than 2. Now, immediately, I know my radius of convergence is 2. As soon as you get it in this form, x plus a number is less than another number, this is your radius of convergence. And it's possible that this will be a little bit more complicated to find out what your radius is. We use our inequalities. So x has got to be between -3 and 1. All right, so we have our radius. Now we need to check the endpoints at x equal -3. What does my series become? Well, I need to go back up. Let's see, I need some space. It's the sum. N goes from 0 to infinity, -1 to the n, -3 plus 1 to the n, divided by 2 to the n. So this is a sum as n goes from 0 to infinity of -1 to the n, and this is what, -2 to the n, divided by 2 to the n. I can do some combining here. So this becomes the sum. N goes from 0 to infinity. Now this is -1 to the n, and this is -1 to the n. So this is -1 to the 2n. So this becomes just 1. And this diverges. Now let's look at x equal 3. Excuse me, at x equal 1. This becomes a sum as n goes from 0 to infinity of -1 to the n times 1 plus 1 to the n divided by 2 to the n. This is going to be the sum as n goes from 0 to infinity of -1 to the n, 2 over 2 to the n. I'm just rewriting this. So this is the sum as n goes from 0 to infinity of -1 to the n. This also diverges. So my radius of convergence, in this case, is 2, and my interval of convergence is from -3 to +1.